experiment is on specific heat capacity, and what we're going to do is measure the specific heat capacity of this block. This block is made of steel. The specific heat capacity is the energy needed to raise 1 kilogram of material by 1 degree Celsius. So what we're going to do is heat this block for 10 minutes and find the specific heat capacity. Now, we need to be able to work out the energy. So I've set up the circuit here. And what I've got is an ammeter in series with the immersion heater and a voltmeter in parallel. And we can work out the energy every second, or power, by doing current times voltage. Once we've got the power, we can times it by the time to find the energy given in each minute that we heat this material. First, we need to take the starting temperature of the block. Then we can put the immersion heater in and start timing and measure the temperature every 1 minute to see how hot the block gets. So put the immersion heater in and start. Let's fill in the table. So let's start with our temperatures. So this one was 25, 38, 48, 52, 57, 61, 65, 70, 74, 76 and 80. If you look at the bottom of the page, it asks you to work out the power of the heater. And this is the current times the voltage. I'll work it out at the bottom of the page. So power equals current times voltage. And our current reading was 3.71 amps and our voltage was 12.18 volts. If we multiply these two together, we get 45.2 watts. Then, to work out the energy, or the work done, we need to do the power times the time. So our power was 45.2 watts, and our time was 60 seconds. So in every 60 seconds, we give 2,712 joules. So if we fill this in on the table, at 0 we had put in 0 joules of work. But after 60 seconds we put in 2,712 joules of work. After 120 seconds we'd put in double that, 5,424. After 180 seconds we'd put in 3 times 2,712 joules. So 8,136. Then 4 times, 10,848. 5 times, 13,560. 6 times, 16,272. Then 18,984. 21,696, 24,408 and 27,120. The next thing we're going to do is plot these on a graph. Let's have a look at the graph we've got to draw. On the x-axis is work done, and it goes up 5,000, 10,000, 15,000, 20,000, 25,000 and 30,000. And then on the y-axis we've got temperature in degrees Celsius, and that goes up to 80. So our starting value was 25, which is here at 0. And then we went up to 35 degrees. The next one was 48 degrees, here 52, 57, 61, 65, 70, 74, 76, and finally 80. The first part of our graph is quite curved, and we're going to ignore that, and we're going to look at this part of the graph. It goes all the way up like that, and you can draw a best fit line through it. And what we're going to do is to use two of these values. So I'm going to pick this one and this one. If we look, this value here was 48 degrees Celsius and 5,424 joules. And this value up here was our final one at 80 degrees Celsius, and that was 27,120 joules. And both of these lie on the line. So if I draw a triangle before these ones, all the way across here, and all the way up here, we can find the change in the work done, which is equal to 27,120 joules minus 5,424 joules. And this gives us a work done of 21,696 joules. And we can see the change in temperature. Well, the change in temperature is equal to 80 degrees minus 48 degrees. So this gives us a difference of 32 degrees Celsius. The final part of the calculation is to work out the specific heat capacity C, and that's equal to the change in energy divided by the mass times the change in temperature. Now we know the change in energy is 21,696 joules from our calculation before. Our mass is 1 kilogram, and our change in temperature was 32 degrees Celsius. If I look at that on my calculator, I get a specific heat capacity of 678 joules per kilogram degree Celsius. And this is the specific heat capacity for steel. The actual value for specific heat capacity of steel is 216 joules per kilogram degree Celsius. You can see our value is significantly higher, and that's because we lost lots of energy as heat to the room. Can you think of a way that we can lose less heat energy to the room and use more to heat up our steel?